is when velocity is greater than 0. Are we looking at the velocity graph?
Yes.
Check. So that means it's above the x-axis if for this particular graph.
So it's 0 to 2, and then 6 to 10. No, 6 to.
Yeah. So yeah, it's
6 to
yeah. And then backward is when velocity is less than 0. So in this case, it's below the y-axis because we've got the velocity graph. If you had position graph, these are not the same. These rules change.
Okay. I don't think he's, well, maybe in the PowerPoint, I don't remember. So it's 4 to 6 then.
4 to 6. And then sometimes it could ask constant, which it doesn't ask here. Neither. That's from 2 to 4.
Mm-hmm.
Okay. Speed up. So speed up.
So is that like 0 to 1?
Well,
like
let's so acceleration is greater than 0.
Okay.
And because you're looking at the velocity graph, it's when the slope is positive.
Okay, so it would be 0 to 1.
Okay.
5 to 6.
5 to 7.
Oh, 5 to 7. Yes, 5 to 7.
So one of the things I didn't say yesterday, but I would almost do it here is I would almost redraw it, like it goes up, down, straight, down. That last part got a little bad, but basically it's yes, all of this, yes. Like you don't care whether it's above or below the axis, it's the slope positive.
Okay. So then slowing down is slope negative, right?
Because you got the velocity graph.
Okay.
Position graph, it's something different, but I mean that's what we can go with. So slope negative.
So then that's 1 to 2, 4 to 5, 8 to 10.
Yes.
Okay.
Sorry, I gave you bad information. We just did part B. Sorry. The speeding up, slowing down depends on whether velocity is positive or negative at the same time. So, well, everything I just said, sorry, it's we just this we did for acceleration. We're gonna have to go through this one more time. So the acceleration is what we just did, and now we can let me back up. Now we can talk about whether something is speeding up or slowing down. So it's speeding up.
What? So
if
when it's the particle's acceleration is 0, then is that 2 to 4 and 7 to 8?
Let's say that one more time. I didn't get
the other part of B is when it's 0. So is that 2 to 4 and 7 to 8?
Yes.
Okay.
Okay. Now from driving, you know that something is speeding up if the velocity is greater than 0 and the acceleration is greater than 0. Both have to be true. So we're looking for two things. We're looking for it to be above the x-axis and to have a positive slope, which is 0 to 1.
Okay.
But not 5 to 7, because from 5 to 6, it's below the x-axis. But from 6 to 7, it's above the x-axis.
So that's speeding up, right?
Yes, it has to have both a positive velocity and acceleration. That's
so slope, so above x-axis and slope positive.
Yes, because there's other possibilities right here, like the velocity. Well, I mean, they're weird, but so the other one is your velocity is greater than 0 and your acceleration is less than 0. This is slowing down. So like this is you're moving forward in your car, acceleration less than 0 means you press on the brake.
Okay. So then it's just 0 to 1.
No,
6 to 7 too?
It's 1 to 2 because the velocity is positive, but the acceleration is negative.
Oh, well, no, for speeding up though.
Oh, for speeding up, it's 0 to 1 and 6 to 7.
Okay, and then speed, and then slowing down is 1 to 2, 8 to 10.
Yes.
Oh, why did I put on mine that it's also for speeding up? I wrote 4 to 5 and then also 5 to 6. And we did the same class, so I'm confused.
Okay, so let's talk about what's happening from 4 to 5. Okay, so from 4 to 5, we need to know what is the velocity. The velocity is less than 0. Okay.
Okay.
What is the acceleration there? Is it positive or negative? Is the slope positive or negative?
Negative.
Negative. So this is like you going backwards, and then you're pressing down the gas to go backwards faster. So you are speeding up here. Because
so confusing.
so these are also the possibilities. Okay, so we can summarize here and say that you're speeding up in the following scenarios. The velocity greater than 0 and the acceleration greater than 0 is one of them. The other one is velocity less than 0 and acceleration less than 0.
So just to clarify, velocity is like above x-axis, below x-axis, and then acceleration is like slope.
Slope of velocity.
Okay.
Again, I can't emphasize enough, like, and it does change example number 2.
Yeah.
If you get the position function, all these rules change, and
yeah,
like they slide up and down based on what you're whether you're given the position or the velocity function.
right.
Okay, and then you're slowing down in the other scenarios. So the first one is you're going forward and you hit the gas. The other one is you're going backwards, and then you hit the gas to go forward. So it's like these are opposite in sign, and these are the same.
Okay.
So somehow I got to get this down. In some ways, the equation is easier, but if you do line where the instructor came over here and said, like, here's 2, 4, 6, and 10, and like for velocity, it's positive, 0, negative, positive, negative. Did you get any of that in class?
Yeah, it's on the, I think we did that on, or it was on one of the PowerPoints that I sent you.
And then acceleration at 1 is from 0 to 1, it's positive, then it's negative, then it 2 is 0, and then it's negative, and then it's positive, and then it's 0, and then it's negative. And these line up, like you end up lining these up with numbers, and that's what we're going to do in the next question. But so what I was trying to show you, if we could just go back a little bit, is that because you're given the velocity graph, if you're above the x-axis, velocity is positive. If you're below the x-axis, velocity is negative.
Right.
Acceleration only has to do with the slope of this graph.
Okay.
And slope negative. And then we can actually answer these questions. Like, you have to actually like do it in this order. Like, you can't tell if it's speeding up or slowing down until you know those things. And you know, like, that summary. It's speeding up if both V and A are positive, V and A are negative, and slowing down when they're opposites. Like, one's positive, one's negative, one's negative.
But why can't you do that part without doing A first? It's like,
well, you can't. It's just harder because you gotta synthesize 2 pieces of information. You have to know that, like, and you would get maybe disjointed piece of information. So from 0 to 1, it's positive velocity, and acceleration is positive, so it's speeding up.
yeah. Okay.
1 to 2, it is positive velocity, but acceleration is negative, so it's slowing down.
I see. Okay.
2 to 4, it's not moving because velocity is equal to 0. 4 to 5, it has negative velocity because it's down here, and acceleration is negative, so it's speeding up. in the negative direction. From 5 to 6, you can see again, like the velocity is negative, but the acceleration is positive. So that means it's slowing down. So it's like you hit the gas real hard to go backwards, and then you hit the gas to go forwards, which is a little weird, but that's what that, or you're slowing down, like you come to a stop. But then your velocity is positive and your acceleration is positive, so you're speeding up.
Okay.
Here, velocity is positive, like like from 7 to 8, maybe like that means you're just constant velocity, but you're not on the gas. You're sort of like on the interstate cruising, but your velocity is positive. You're going forward, and then here your velocity is still positive, but your acceleration is negative because it's a slope, so you're slowing down.
Okay.
I don't think that's as helpful as this, but you gotta figure out what works for you, I guess. On here.
So then for C.
C, okay.
So greatest speed, that would just be like when it's like the highest y value. Like
it's the max of the V graph. So that's right there.
7 to 8, but then what about t equals 5? Why is that there?
I don't know.
Well, we did it in so it's like, I think that was like one instance but I'm confused.
I'm trying to look at your answers here. Where's part C? Oh, there it is, 7 to 8.
The top. Maybe, well, does it apply to like the below the x-axis too?
It would, but it's not as far down as the other one is up, as far as I can tell. Like it goes down.
Yeah, just -3.
Oh, does it go down to -3? Okay, it was hard to tell. Yeah.
Oh, I see. It's the same. It's the
yeah. Okay. Then yes, that's why it's down there.
Got it. Okay.
When does the particle stand still for more than an instant? So
does that mean like more than 2 seconds, basically?
Well, at 6, its velocity is equal to 0, but that's instantaneous. Like it's traveling right through that.
Right. So then for 7 and 8, it's only for like 1.
No, its velocity is not 0 from 7 to 8. The velocity is 3. That's from 7 to 8.
But it's just staying at 3. I see.
It's staying at 3. So up here, its acceleration is actually equal to 0 because it's constant velocity.
So then from 2 to 4, it's a and both acceleration and velocity.
Yes,
equal, right?
exactly. Yeah. Okay. Yeah. So there's so much you can get from these graphs, but there's so much here. I truly, this is hard to understand. Then you see this again in physics if you take that.
Yeah, I get like everything except for like the speeding up, slowing. Like I get it, but it's like it's only like really fun thing.
I find it's only kind of weird when you're going negative, like velocity less than 0. It's like it's because your car doesn't measure velocity, measures speed, but it's like something going the other direction faster and faster and faster.
Right.
So you maybe just have to get these down and say if these are the same sign, then speeding up, slowing down, opposite sign.
Okay.
Should we move on to example 2?
Yeah.
Okay. So for example 2, I'm going to write the equation down. S of t equals minus t cubed plus 15t squared minus 32t plus 14. So part A says to find the instantaneous velocity at any time t. In other words, that's the derivative v of t is equal to s prime of t. The derivative of position is velocity. And you
so 3t.
Well, there's a negative in the original, I think.
Yeah. So you just already had it there. So
okay. Yeah, I didn't see it in yours, but nevertheless.
Maybe I just forgot that because I put it in part B.
Yeah. Okay. Now this one doesn't Factor? Well, you should expect this to factor in your exam. I'm
Yeah,
actually,
I don't think this was his like worksheet, you know what I mean?
I'm sure to Shaq this doesn't factor. Looking it up now. It does not. So, okay, then and whether you do it in this step or not, you're most likely going to have to take yet another derivative. Oh, and that is part B. So part B is to find the acceleration. Acceleration of t is the derivative. I'm sorry, it's the derivative. It's v prime of t or s double prime of t. So that's minus 6t plus 30 equals 0.
Okay.
All right. So when is the particle at rest? So like with C, you have to know you have to know that what they're asking. They're asking for velocity being 0. So when is velocity 0? They're asking when this equation up here, when is minus 3t squared plus 30.
Oh, so is that why you need to factor it? Is that why you?
Well, you should plan on factoring it in on the exam, but or this is the calculator section and then you don't need it.
Well,
Or you just graph it to find that out. Sorry, go ahead.
or can you use like a quadratic equation too?
Yes, slow graphing is your go-to on this.
Okay.
Let me snip in the graph so that we can look at it
I
together.
need to remember the quadratic formula.
You do, yeah, you absolutely do. But you get to a point there where actually you just graph stuff. I mean, maybe I'm overseeing. So it's 0 at these two places. You know, 1.24, 8.786. Is that what you got when you're?
No.
You have 3t squared though. You see how that changes this? Not. Yeah. So yours. Yeah. So the negative does change that quite a bit. It's the negative there. And
Is that if it was positive, would that make sense?
Yes,
No.
that's
Okay.
the right value. Okay. So then so it's at rest there. Now this is the V graph. We should talk about a few things on this V graph because that's so and obviously this connects back here. So V is positive in this window, right?
Wait, so
what?
I'm sorry, the particles are at rest at 1.214 and
8.786.
Okay.
Yeah. Yes. So just to relate this to the last question a little bit here, when the velocity is greater than 0 when it's above the x-axis, and velocity is less than 0 when it's below the x-axis. That's just like the last problem we did.
Okay.
And that affects, that leads into part D. At what value of t does the particle change directions? So it changes directions when velocity goes from positive to negative, or velocity goes from negative to positive. Essentially, a crossing.
So it's the same, it's the zeros again.
Yes, yes, it's those two answers.
And you write them as like ordered pairs?
Just the t values, just t equals 1.214, t equals 8.786. Now, based on this, if I were to show you a graph like this, and this is V and this is T, which points does it change directions? There's that's A and that's B.
Just B.
Just B, because that's the only crossing. So it doesn't matter if it touches or bounces, it's got to cross.
Okay.
Is that okay?
Yeah, that makes sense.
Okay. Now it didn't ask for it, but here I'll ask you part E. When is the acceleration equal to 0? And let me
So
I'm
do
gonna,
you use, oh wait, do you use 6t plus 30 equals 0?
yes.
Okay. So it would be negative 6t equals minus 30. So I don't know, 30 divided by, or yeah, 30 over 6, which is
So t equals 5, and this is the velocity graph. Okay. So what is the slope here at this top?
0.
And that's the acceleration is the slope of the velocity.
Okay.
Because you may not have the equation, you might be given the graph.
Okay.
All right, great. That closes out that question. Moving on to example 3.
Yeah.
Okay. Minus t cubed plus 9t squared minus 15t. Okay. So what's the velocity of this? How do you find that?
The derivative.
Derivative. So that's minus 3t squared plus 18t minus 15. It does ask when the velocity is 0. So you set this equal to 0, and this is now a pre-calculus algebra 2 question. It's simply factoring something to equal 0.
So then it's 1, 5, or negative 5 and negative 1.
Yes. So it's at t equals 1, t
5.
equals 5. Okay. Now it also asks when acceleration is 0. So you got to find the acceleration.
So derivative of that derivative.
Yep. Minus 16t plus 18 equals 0, and that equals 0 when t equals 3.
I have a question. When it asks for like the fourth derivative,
Yes.
you have to do like all the derivatives before it to get to
That's
the
right.
one.
That's
Okay.
right. But you had an example of there of like sine, the 15th derivative sine. That one has a pattern that you can use.
Oh, okay. Can we go over that after we finish this?
Sure. We need to just a tiny bit of graphing here, I think, to make sure we understand this. So the acceleration graph looks like this. Assume that that's 3. Okay. And the velocity graph, it looks something like this, where that's also 3.
Okay.
Actually, that's not the greatest graph. Let me graph, because I think this would be worth covering. And let me graph this nicer on the computer here. X minus 1, and then we'll do for x greater than 0, and then minus 6x plus 18. All right. Actually, let me not graph that one quite yet. Okay. Let me step this in. Okay, so here's the graph of velocity of the one we just did, velocity and time. So and this is 1, and this is 5, and this is 6. Like, assume it stops there. Okay. When is the velocity greater than 0?
1, 2, 5.
Okay. When is velocity less than 0?
0 to 1, and then 5 to
to 6. We're going to say it ends there at 6.
Okay.
When is acceleration now positive? Now acceleration is what in relationship to this graph? There's a one word answer I'm looking for.
Slope.
Slope. So when is the slope going up and to the right from 0 to what value?
1 to 3. Oh no.
0 to 3.
3.
When is acceleration negative?
3 to 6.
Okay. Now, when is it speeding up? So speeding up is two situations. It's when velocity is positive and acceleration is positive, or velocity is negative and acceleration is negative.
So it would be okay, velocity positive, acceleration positive. So 1 to 3.
Okay, agreed.
And then velocity negative, acceleration negative. So 5 to 6.
Yes, because it's got to be going down and slope. It's got to be below the x-axis and going down. Now it's kind of cheating because the slowing down is the other ones, but let's make sure.
I see what you were saying. Like they both have to have the same signs. Like
yes.
Okay, gotcha.
Great. I'm glad this helped. Slowing down is the other windows, but let's look at why. So from 0 to 1, velocity is negative because it's below the x-axis, but the acceleration is positive because it's going positive slope. But it's the other intervals, like it's either one or the other.
Okay.
And then from 3 to 5, so let's look at that. Well, the velocity is positive because it's above the x-axis, but the slope is negative because it's going down.
Right. Okay.
Where is velocity equal to 0? You've already answered this, but it's at t equals 1 and t equals 5. So what happens at t equals 1? Is it a what do you see there? We kind of already covered this in another problem.
It's a 0. Well, it's a 0.
So in the previous problem, we talked about changing crossings, part D, changing directions.
Right. Oh, so at what value? Yeah.
So
okay.
t equals 1, it's changing directions. Same thing at t equals 5, it's changing directions.
Right. And then at t equals 3, it's
what is the acceleration equal to at t
it's at
equals
rest,
3?
right?
Well, it's also at rest at 1 and 5.
Yes.
It's not at rest at 3.
Oh.
It's acceleration at 0 because the velocity is right there. It's whatever it is.
Right. Okay.
Really close. Like you got 95% of that down, which is really good. So the acceleration is equal to 0. Velocity is not 0. It's whatever. It's 15-ish. Okay, so now we can look at your PowerPoints if you would like. But let's talk about sine. That was the one here. So let's say y equals sine of x. What is the derivative of sine? Cosine of x. Derivative of cosine is minus sine of x.
Right. Oh, so it's just the odd ones are going to be like the cosine.
This is minus cosine of x, and then y to the 4th is sine of x. And then it repeats.
Okay.
So y to the 5th is cosine of x. Y to the 6th is minus sine x.
So would you only get that for like a sine one?
No, your instructor could start out with any of these, and then you have to figure out
where you would do it for like a tangent.
Tangent doesn't pattern. So you're going to start out with one of these 4.
Okay.
And you just have to figure out the pattern, and so let's say or minus cosine x, y to the 8th is sine x again. So if I give you the the 112th derivative, which one of these does it map to? And you divide it by 4. If you don't remember that. So 112 divided by 4 is
28.
So it has as a remainder of 0. So the 0 is this last one.
Oh, so if it doesn't, so if it was like 113 divided by 4, it would be cosine.
That's right. That's how you do it.
Gotcha. Okay.
This is remainder of 1, remainder of 2, remainder of 3, remainder of 0.
Okay, that makes sense.
Okay, so now what do you want to look at for game plan 3.4, 3.5? Where should we go for that?
Yeah, so there was one thing that I didn't really, hold on, let me find it. Okay, so change direction is when it crosses the X. Oh, so on slide, what is this slide? On 3.415. Show the motion using parametric graphing. Actually, maybe we can just run through this one.
This 3.5 or 3.4?
It's in 3.4.
This would be a good graph for us to go through again if you wanted to also.
Okay.
Which slide?
15.
Just 15 here. This tool doesn't tell me which slide. This one right here. Particle motion. Oh, I'm sorry. Is it the particle motion slide?
Yes.
Okay. All right, a particle moves along a line so that's positioned at any time is given by the function t squared minus 4t, where t measured meters, so on and so on. Okay, and then a question, do you want to go through all the questions or certain ones?
Well, we can just go through all of them.
Okay, so displacement is not calculus. It's essentially finding s of 2 and subtracting s of 0.
So you plug it. So you plug it. Okay.
So s of 2 is 2 squared minus 4 times 2 plus 3. And that's 4 minus 8 plus 3. So that's minus 1. And then s of 0 is 0 squared minus 4 times 0 plus 3. So that's 3.
Well, it doesn't matter that it's 0 to 2. You can still do 2 minus 0 rather than 0 minus 2.
So this is like this whole like displacement is how far you are from where you started. So if you go around a track, your displacement could be 0, but your distance is all the way around. So we just care like how far is it away from those two. It's a little odd, but
Okay, that's fine.
I mean, you can check your answer. I mean, that's not the real emphasis of this question. It's part B, and B through F. So let me jump to those. The average velocity, and see, there's so many things thrown at you. This is where it gets confusing because as a student, because you're just barely learning this. The average velocity, this is average rate of change. So this is s of 4 minus s of 0 over 4 minus 0. And see how that's
that equation. Okay.
Yes, and it's because it says average velocity. If it said velocity, you would find the derivative because it's average velocity, it's average rate of change thing that you've already figured out. So let's get some of those numbers here. All right, so s of 4 is equal to 3, and s of 0 we already found, that's also equal to 3. So it ends up being 3 minus 3 over 4, which is 0 over 4, which equals 0. Part C is the instantaneous velocity. Instantaneous means derivative. That's the stuff that you're learning this chapter. That's new. That's the calculus stuff. So that's the derivative. That's the power rule here for all of these. So your v of t, which is really the derivative of position, is 2t minus 4. A lot of times it asks you where the velocity is equal to 0. So maybe we'll do that for C.1. Velocity equals 0 when 2t minus 4 equals 0. So t equals 2.
Okay.
And then the next question, oh no, I'm sorry. It
At
wants the
4.
velocity at 4. So you have to find v of 4. So v of 4 is 2 times 4 minus 4.
So 4.
So 4. Yeah, a lot of 4s. So that equals 4. And then D, it says to find the acceleration at t equals 4. So same thing. You're going to find the derivative of the velocity or the second derivative. So your acceleration of t is just 2. And what that means is acceleration is always 2.
Oh wait, how do you know that it's 2?
It's the constant, the derivative of 2t minus 4.
Oh.
So it's the c, they can write it this way: d dx of cx always equals c.
Gotcha. Okay.
And d dx of a constant always equals 0, which is why the second one is 0. That means acceleration is always 2, means it's always accelerating, which is ridiculous, but that's what this problem says.
Wait, so which one would be 0?
None of the second term, the derivative of minus 4.
Oh, okay, I see.
Yeah. Describe the motion of the particle. So let's look at the velocity graph here. So we said velocity is 2t minus 4. So the graph of that, let's see if I can get a good clean graph of that. So we're starting at minus 4. We'll go right there, minus 4. And then we're going up 2, up 2, up 2, up 2. So let's just do it right there. Velocity and t. Okay, so what's going on? What's going on in this region right here? When is velocity less than 0? When is velocity greater than 0?
Less than 0 from 0 to 2.
2. And greater than 0?
2 to 4. Infinity.
Yeah, we don't. It says t greater than or equal to 0 in the problem, so you know that means forever.
Okay.
When is acceleration greater than 0? So that's asking, when does this thing have positive slope?
Always.
Always. So it's not minus infinity though, it's 0 to infinity because it starts there. And that's what this means. So again, kind of repeat it. When is it speeding up?
So speeding up from 2 to infinity.
2 to infinity. When is it slowing down?
0 to 2.
0 to 2. When does it change directions?
2.
At t equals 2. When is the velocity equal 0? T equals 2. I think that covers it.
Okay, that makes so much more sense.
So you want to, just to be clear, we've only been looking at velocity graphs. So to do your analysis, you want to look at velocity graphs.
Right. I don't think he's given us any position.
Well, he didn't give you a graph on this one, but we created one from the velocity function.
Right, but that's still, it's not like a position question, right? It's a velocity question.
Yes, the positions are kind of irrelevant.
Because the only position ones he gave us were like words, not graphs.
Okay.
On the worksheet, at least.
There is a summary here. Velocity acceleration summary. I think the same signs is going to be more clear. There's also another graph in 3.4 if you want us to look at it one more time.
Well, isn't there one more question on this one? Oh,
Show the motions using parametric graphing. I mean,
yeah.
we did that. That's
Oh, that's that. Oh,
yes.
I see. Okay.
And so A of t is not very interesting, but A of t looks like this. It's always 2.
Oh,
Because it's always 2. A equals 2.
Oh, okay. Yeah, we can look at the other graph.
Okay. The other graph is well, here's this a good one. So again, you're getting V of t this time.
Okay. So it's
Let's go through a few of these. Where is velocity greater than 0?
0 to 1 and 5 to 6.
So 0 to 3 and 5 to 6, 5 to 8.
Oh, yeah, that one's the all above x-axis, right?
Yes.
So that's like the moving right, or what is it called? Moving forward, right? Like when does the particle move forward is how it would be like phrased, right?
Well, it's moving forward when its V is greater than 0.
Right, isn't that what you just asked? V is greater than 0?
Well, yeah, so it's wherever it's above the x-axis.
Yeah, but so like, but if they were asking this like on the worksheets, like it said like when does the particle move forward, this would be the same.
So it's moving forward when it's above the x-axis.
Yes, okay. So then it's when V is less than 0, it's 3 to 5 and that's it.
Yeah. So then where is it less than 0? That's where it's moving backwards.
Yeah, so just 3 to 5.
And where is velocity equal to 0? And it's only here from 8 to 10 because it's actually on
The x-axis. So then it's speeding up from 0 to 1.
That's right.
And then 3, no. Yes, 3 to 4. And then 5 to 6, right?
Yes. So this region right here is speeding up.
What about 3 to 4?
And 3 to 4. And 3 to 4 because it's going down and down. These are all speeding up.
And then slowing down is 2 to 3 and 4 to 5, 6 to 8.
Yes, in the other regions, it's slowing down. So let me do it in the blue here, or the red, because it's already in red. These are the slowing down regions.
Okay. So then if it was like greatest speed, it would be at 1 to 2, t equals 4, and t equals 6, right?
So these are, yeah, it's these windows, 2 to 3, 4 to 5.
Well, but if it was asking like where is it at its greatest speed, it would be 1 to 2, 4, and 6, right?
Say that one more time.
For greatest speed.
Greatest speed is both places, both here. Let me do a different color. This is greatest speed.
Okay. And then it's like at rest at
when velocity equals zero.
So 0, 3, 5, and 8. No, sorry. 8 to 10.
So its velocity is equal to 0 from 8 to 10, and these other places where it's instantaneously equal to 0.
Oh, so I was right. Okay, so does 0 count too?
Yeah, it kind of does, because it is defined there.
So 0, 3, 5, and then 8 to 10.
Right.
And then acceleration is 0 at 1 to 2 as well, but
That's
not
right.
velocity, right? Velocity is 4.
Yes.
Okay, just making sure. Okay.
All right, I think that's everything for today. I think that's kind of going to make everything, I think that's everything to cover. I think you'll be okay on the exam. And
I think that was the last thing I want to cover. So perfect.
all right, great. I will send you the notes and the screen recording out shortly.
Okay, thank you.
You're welcome. Have a great night. Bye now.
Bye.